started another one. And don't feel bad about hijacking because I don't have that much. I just wanted to share what's been going through my mind, and you know, maybe by talking through it, get more ideas for myself and from you, like on how to proceed and how to deal with these kind of use cases. So you're okay for me to start?
Yeah, go ahead.
Let me share the screen. I'm on a laptop, so I'll share this whole screen. I hope you see it.
Yeah, I can see a GitHub repo in a browser.
Perfect. That's where we're starting. So let me increase a little bit. So first, just an idea of you know, how things work with the BLE mesh, what we try to do, how it works without containers, what we try to do it to make it work on the containers and the Kubernetes. And this is like a POC we have at the moment, and then, you know, talk about all these challenges and where we're gonna go further with all this. I hope to you know, get a more clear picture of how to deal with this. So the idea is there's a BLE as a standard, right? Which is similar to the standard Bluetooth. It can be connection between the device and, so to say, the gateway, or it can work in a more advertising mode. But there's also a BLE mesh, which is a spec on top of the Bluetooth Low Energy, which allows basically to have a lot of devices, you know, with a near proximity, just broadcasting things between themselves and figuring out in a typical mesh way the whole application. So what we trying to do is create a lot more better experience for BLE mesh, starting from the device, using embedded Rust and Embassy to build proper drivers and the stack for devices to be able to participate in a BLE mesh, and basically connect that to our Draw Cloud project to be able to provision, manage those devices, get the telemetry from them, send the commands, and you know, connect the cloud applications like digital twins and everything into that picture. But to go from the mesh to the cloud, you need some kind of gateway or so to say edge stack to basically offload things from the Bluetooth mesh and put it to the cloud. So how
are you willing to take questions now, or do you want to just keep?
Yeah, I want this to be completely interactive. So let's just talk about it.
So I want to make sure I understand the diagram then, that you'd have workloads, which I guess is like your device app in this diagram, right? So this other pod to the left is kind of the enablement to use transport to the cloud and point-to-point over the Bluetooth Low Energy.
Yeah. So how all these mesh things work on a pure Linux box is that you will have a mesh D. That's a Bluetooth mesh daemon, which communicates directly with the device, usually the HCWA. No.
So that's like a Linux OS device.
Yeah.
And
yeah.
In order to get that to work in Docker, then does it have to run as a privileged container to get access?
Yeah. We'll get to that. Yeah.
Okay.
But basically, yeah. The daemon talks to the radio, and it's being able to get everything from the mesh, and it communicates with the rest of the system using the dbus, which is a typical thing again for the Linux thing. It's like a a bus for messages for inter-process communication on the Linux, right? So if you wanna create an application that will communicate with the mesh daemon, you need to be able to talk dbus, and there's two kind of buses that's there. There's a session bus and there's a system bus. The mesh daemon is using the system bus to send events basically of what's going on the radio. And the final thing you need for this, because this mesh daemon is basically holding a lot of state, meaning it needs to know all the devices it's communicate with, it needs to know all the keys, and there's needs to be a provisioning process for a device to actually join the mesh. So there's a as you can see here, there's two things.
So those would be like volume
stateful
mounts in Docker.
Yeah, in Docker, but talking just from the pure Linux box perspective, these are the three things you would need. You would need access to the device. You would need a couple of folders for storing the configuration and the state, and you need access to the dbus for you to be able to communicate with the.
Can I ask you
rest of the system? Yeah.
Can I ask why you chose to use dbus instead of an alternative? Would have been to use a network connection between those two pods, right?
It's not a decision we made. That's how the mesh daemon in a Bluesy in a Linux stack works.
Okay.
So that's implementation.
So it was just something that was already there, as opposed to, for all I know, one has performance advantages or latency advantages, and I just don't know enough to know, but I was just curious.
Yeah, I think, go ahead, Kate.
I was just curious if you're using Bluesy, and you mentioned you're using like some, it sounds like REST applications. Are you using the Bluer crate?
Yeah, we'll get there. Yeah, so
okay.
Sorry. That's in the no worries. It's all good questions, because it took me a while. Like I said, okay, yeah, I'll get to do this part, because other folks are working on the firmware side, and some folks are covering the cloud. So I started digging into this, and this is what I found. So at the moment, so yeah, the mesh daemon is written in C, and it's using the dbus to be able to connect to other application on the host. That's how system is. And the gateway app, the first thing that I did is create a small POC in Python, because that's the only examples that I found at the moment. And the thing with Bluesy, it's a C for the daemon stuff, and all tooling is in the Python. As you said, there's a Bluer crate that I started looking at, and it's working with a BLE, but there's nothing supported yet on the BLE mesh side. So that's something that we are gonna tackle in the future. Hopefully, we'll have enough time and resources to actually contribute a proper BLE mesh stack into a Bluer, so that things can work there. And that's important because. So I'm jumping a little bit ahead of me here, because I wanted to talk about it later on, but yeah, there's some issues here, because this stack is not that well developed yet. So that there are things missing. And basically, what we had in mind first is to so how to make this work is when you start the gateway, right? It needs to have some state, or you need to be able to create that state from somewhere. So we envisioned that we'll have like a number of devices. For example, think about the typical conference demo use case. you will come with a lot of devices pre-provisioned. So we'll already have this state pre-created, right? And the particular part about the current BLE mesh stack right now is that this provisioning part in configuration part needs a lot of love because the only thing we have at the moment is you can provision a device at a time using the interactive command line tool, which you can't automate, you can't script, you know, and things like that. So my idea and the plan we're trying to start working on this week is to, when we start contributing to the Blue, first tackle that provisioning APIs first, so that we can automate provisioning of devices and you know, being able to kick off the provisioning from the cloud, or maybe, you know, using some CRDs and you know, have a better integration into the Kubernetes or whatever, or even just having a proper CLI that we can script and do this with a large number of devices. So that's one of the things.
So when you're mentioning provisioning the devices via BlueZ, is there certain endpoints that every like BlueZ compliant device supports for provisioning? So what type of provisioning are you talking about? Like what are you changing about the device?
So there needs to be a handshake between the device and the provisioner or the gateway in this case for the device to be able to join the mesh. So basically, when you turn on device, I need to dig a little bit more into this, but this is my current understanding how this works. So you get your microcontroller device, you boot it up, and it will start broadcasting its ID, UUID, over the Bluetooth mesh, right? And it would be seen by everybody else, even and the provisioner app as well. Then somebody needs to say on the provisioner app, say, okay, you know, provision this device, right? And then that's where the handshake between the gateway app and the actual device is actually being started. They need to exchange the keys, and if the security is enabled, there needs to be something like, depending on the device, you would need to you will need to enter some passcode on the device or something like that to verify that you know you're who you are, right? After that, you join the mesh and you get your mesh ID basically. So consider it like a topic name, address, mesh address. And this is the address you use later on to send your packets, and you are able to receive the packets on that address as well from other devices in the mesh.
Great, that makes sense. Yeah. So
okay.
Provisioning, just to state it back, in this context means to add it to the mesh.
Yeah.
Okay.
Yeah.
I just wanted to make sure it wasn't like flashing some new firmware onto some Bluetooth device in that sense of provisioning. So that helps clarify that.
Yeah, but once the device is provisioned, it usually gets a token as a result of that, and that token should be stored somewhere that, you know, when the device reboots, it can join the mesh without provisioning. So you can have pre-provisioned devices, so to say, and when you turn it off, turn it on, if it has all the keys and it has its own token, it can just attach to the mesh without needing to be provisioned. Sorry. Yeah. again. Is that makes
Just
sense?
one other question, I guess. So this picture is an example of provisioning that one device to join the mesh.
Yeah.
So clarifying, we don't have any other Bluetooth devices in this picture, right?
Yeah, we have this one, and this is what I use as a device simulator. So it's actually a proper Bluetooth mesh device, but it's living on the same host as the gateway, and it's basically using the DBus to present itself as a device on the mesh. So it actually event sends from the device app, which is like again Python app, will go through the dbus to the mesh daemon, and actually will be distributed to all the other devices in the mesh.
So is that a
Make
common
sense?
practice for an application to join the mesh in order to interact with the devices? Is that kind of how it works?
Not that I see a lot of it, but I found it very useful for the testing purposes. First, one less thing to but actually you can see that it is right, because your Linux container doesn't need to be only a gateway, right? It can have multiple workloads that are actually behaving like a Bluetooth devices, right? So there's nothing wrong in actually implementing it like that, and interacting with the rest of devices in the mesh. What I envision in the future as well. So first value here is that you can test all these things without actually having to have a physical microcontroller and flash it or everything. So this is you can run all these as I'll show you a little bit later, just as a payload on the Kubernetes, right? In these terms, everything will run on the single host. But if you have a multiple host, that will work, because it will all go to the host radio and be emitted to other nodes in the area.
So I'm trying to understand, are you trying to come up with an API to handle this, like device onboarding and things, or is there an existing one that you're just trying to use?
What we try to do is actually make it usable.
So
as you see,
to invent your own API, if you will, so that this could be used programmatically.
Yeah. So
okay,
start from the bottom up. Improve the stack that it can be used, on its own a little bit easier, and be more programmable, so that we can add more APIs and integrate it better in our Draw cloud with our firmware, but also being able to integrate it in any other solution that wants to use it, because that's very hard thing to do today.
So in chat, I don't know if this is relevant or not, but I think it might be. And it looks like there's an Android API for doing this BLE onboarding. So maybe that's a decent model to look at somebody else who tried, if that's a similar enough problem going on. Maybe there's something to be learned by looking at that.
It's a different problem. So that's what I said. There's a BLE and there's a BLE mesh. And the BLE is much better better supported at the moment, but the mesh thing is still a thing in development, and yeah, for one reason or another, we decided to focus on the mesh as a thing that we wanna play with and continue developing for this kind of use case. But I think it's from like thinking and just to finish on this device app, what I think it's also will be useful at some point is that will be will be useful to have something like this to be able to do a scale testing at some point, because it's much easier to run 100 pods and test, you know, if your gateway and your edge architecture can support all that traffic, instead of you know, needing to flash and boot 100 physical devices and try to run everything that way. But what's interesting to me is that, you know, this use case shows one kind of workload that I think pushes a little bit this edge workloads, you know, to its boundaries, at least from what I see so far, because, you know, our service needs to have a proper proper access to the physical host device. It needs to maintain a lot of state locally, and it needs to be able to communicate with other local services over the DBus, right? So it's a three hurdles to solve that you usually don't see in the cloud when trying to develop your services. So let me show you what we have at the moment. And as I said, like this is basically a POC that's working. But as I said, the idea, you know, the ideal scenario would be that this could be easily provisioned using Argo CD or some kind of a cluster management tool that will hook up everything to the cloud, and then the cloud, you know, device registry can manage the state of the gateway and the mesh itself. But that's some way to go to get to there. So this is at the moment how things work. This is the deployment of, for example, the gateway service. The entry point will start the local mesh daemon. So I was experimenting a lot about, you know, where each of these things should live or not, and you can easily see that you can start the mesh daemon even on the host as well, and then you use just to keep all the state outside of the containers. But I ended up thinking that it's good to have a containerized mesh and mesh state, because it's much easier to replicate that over the multiple systems, because otherwise you would need something else like Ansible or something else to get your host to the proper state even before you can run your workload. Like this, your workload actually own this state through the volumes and starting a daemon internally, right? And for the state, yeah, currently I have just the two volumes that contains this pre-provision state. As I said, it works nicely if you have something that you pre-provisioned. You have a lot of this state is a bunch of JSON files, so it's easy enough to mount into the volumes. But for example, if in this current state of things you want to add new device, you would need to basically exit into this pod, run the tooling, start the provisioning, and it will update the state and storage. But there's no API I could use today to do this, and the idea is to develop the other one. And as you said, Steve, in order to use to access.
Also, just to let you know, Dan, Steve hopped off just now.
Okay.
Yeah.
Yes, I'm sharing one screen and I don't see you guys.
No worries. He literally just dropped off. So.
Yeah, no worries, no worries. Is this interesting to you? We can continue with it any
No,
other
yeah,
time.
I'm happy to keep listening. I need to hop off at the end of the hour just because it's a
Yeah,
little late
yeah,
here,
yeah,
but
yeah.
I'm really interested in this. It's actually quite interesting. We in our community meeting this morning, someone proposed a discovery handler for Ocre for Bluetooth. And
Yeah.
that's why we were discussing like the Blue Air crate, which is a little under maintained compared to another Rest crate that I don't remember what it was, but Blue Air is based off Blue Z, which is very established. But anyways, so this is really
Yeah.
interesting because it's, I mean, clearly similar landscapes as Ocre. And yeah, I'm enjoying
Yeah.
hearing about all this.
My idea would be to discuss at some point how we can, hook up Acre in the picture as well, right? And as you said,
Yeah.
going into the same direction. But currently, I haven't seen anything in Acre that would help with this stateful edge services, right? So that's why I wanted also to pick your mind about all these things
Yeah.
and
Which
see,
one is stateful in this image? Where are you thinking of something being stateful?
so this one, right? This pod that contains the gateway, which needs to have a mesh process. It actually needs to have access to the volumes to be able to have the state of the mesh, right?
Mm-hmm. But you're only deploying one of those per mesh, right? Or one per
Not
node.
necessarily, right? So
Okay.
this is just let me show you how it works today. So we have the security context. So it needs to be a privileged container, so it can access the actual radio device, right? And we need to mount these volumes containing the mesh state, so that the mesh daemon running inside of it can work properly. And in the end, we need to mount the dbus socket to enable the communication with the outside world on the same node. Basically, this is only needed if you want to run another services on the same node that will act as a Bluetooth mesh devices or Bluetooth devices in general, right?
Mm-hmm.
Make sense?
Yeah. So
Yeah.
remind me what information the gateway application is sending up to the cloud.
So in the end, everything is provisioned. Mesh daemon is working properly. The gateway joined the app, device joined, this device joined, and then this is just like a service. So these devices sending their updates and publishing their telemetry, basically. And the gateway will get those events, convert them to a MQTT or HTTP payload and send forward. The other way around, if you go from the cloud, send a command for a certain device, the gateway will will send it to the mesh daemon, and mesh daemon will broadcast that, and the proper device will get it. Let me show you. Can you see the console?
Yes.
Cool. So let me increase the font a little bit, right? So, and I'm disconnected. Give me a sec. Cool. So this is the two deployments, these two deployments being deployed, right, on the on the node. And so you can see, for example, let me get just device. So device basically is just sending data, using the Python library that basically talks dbus on a proper channel and sending a properly formatted dbus messages. That's all this app is doing. And then the gateway is basically getting those messages. This is from the other device, right? But it's the same thing. It's listening on the dbus channel. I think that's a proper terminology. Getting all the events there, and then converting those into the API that our cloud project is actually expecting, right? So there's a device model, and it gets converted from the BLE mesh model to the JSON model that cloud expects.
That makes
Sounds
sense.
good?
Yeah.
Yeah. So yeah, it took a while to get to this state. We don't have too much time. Maybe I can yeah stop, because it's easier to talk.
Yeah,
when you
no,
see
I
the
think
face.
I would love to look at it deeper and kind of get even more of a sense of what's going on there. But one of the parts where I'm curious about is, I guess that diagram was actually quite helpful. Let me see. I think I might have it pulled up just to make sure I'm using the right terms for everything.
Okay, I can share it again if it's easier.
Or will you put it in the chat maybe, so then I can pull it up and we can still see, have a conversation. But I'm curious how the mesh D is, how are you configuring the mesh D with all of the keys? And do all of these Bluetooth devices have the same communication API? And how are you, is that a standard among Bluetooth? I'm not super familiar with.
Yeah. So at the moment, this is all pre-provisioned. Yeah. So when you start from the clean, on your provisioner node, you can say there's a tool part of the BlueZ that's configuring the mesh, right? And that's the first part we need to tackle, in order to this be more programmable and more integratable into the bigger ecosystem. But for now, you start that tool and you say create me a mesh, right? And it will create a basic key for the provisioner. I may be missing some things because I didn't dig too deep into it, but that's something next on my plate. So maybe in a month's time we can revisit with more information. And then you create an application key for one application. That's the concept of the BLE mesh spec. And then you basically listen for unprovisioned devices, which will broadcast themselves there. Devices that are available in your surroundings but not being joined the mesh yet, right? And then you say, and device say, I want to join the mesh, and then you say from the provisioner, which is your node, saying provision this ID, this device, and then the handshake begins. Device sends its key, the provisioner sends its key. And there's a couple of keys, network key and application key. And if that's all successful, device is part of the mesh. And that state is written into this storage these volumes that they show you that the mesh daemon is using, right? So in theory, you can then stop the daemon, get these files, these JSON files with keys and everything, and basically containerize it and put it up somewhere else, and you have your mesh with its proper state, right? So that's what I did here. I think that's the value, because the start of this was trying to make something that we can demo at a conference at scale, right? And we want to bring 100 devices there, all pre-provisioned and everything ready. So just boot the NUCs and boot devices, and they should be pre-configured.
Awesome. Yeah, it seems like a really powerful setup. It seems very cool. And I would love to see a demo. Are you wherever and whenever you present it?
Yeah, I just wanted to get into the people's mind what I'm playing with, see if anybody interested into this topic have some experience, get some ideas, because I didn't see much thing on trying to find find things.
Yeah, I mean, I think Bluetooth in general, I'm not super familiar with what scenarios, like production scenarios, are Bluetooth's being used for with and in particular with Bluetooth mesh. I'm not super familiar, so I'd love to learn about that a little bit more too. But and then with the use case scenarios, I would be curious too what y'all are targeting or what you've heard. Like, is the predominant use case having one gateway per mesh that's kind of grabbing all the information and sending it up, or is it multiple?
What we have in our original plan, so our demo was in the end postponed, canceled, because COVID and not enough participants interested into these kind of things. But we are working to complete it and to make it work and present, having it being reproducible on different events. But I think the whole idea with the mesh is that BLE on its own, we are not sure it will be able to scale to like having 500 devices and a single gateway, right? But mesh should if you need to go, we can continue some other way. But
feel free to finish it up your comment.
Yes, so mesh should help with that, because it as a mesh there's a more responsibility and scale offloading from a single node, right? And device and the gateway in the mesh scenario is just one device, right? It gets everything it can get from what it can see, and it can send data further. It just have a role of gateway, but it's a simple device from the mesh perspective. So idea would be to have at least couple of gateways in this kind of scenario. And I think for that, even in my mind, the current idea is that like having a proper 3-node cluster, which each node having like a daemon set, which is a gateway, and then having a Kubernetes cluster that is not stacked, but actually distributed over the wider area, so that you actually have a Bluetooth coverage, and behaving like a one cluster with each node being a gateway and being able to cover the certain area. I think that's something we're heading for. Yeah,
that's really cool.
As an architecture for the edge, right?
Yeah, I think that would be really interesting. Yeah, because you kind of can spread out what devices are visible by spreading out those nodes, which is a really interesting
for every gateway, because I think there's a limit around 200, 300 connections that a BLE can handle. So having a mesh should push us in thousands in theory, right?
Yeah, and I think the interesting thing here, or the question, and we can maybe take this later, but is if that gateway, you have a gateway running on each node, kind of daemon set fashion. If that gateway can kind of enumerate what devices are on each node, then you could bring Aukri in the sense of, say you have applications that you want to only be deployed to the node that has that device. If you use Aukri to create Kubernetes resources for each of the devices that your mesh advertises, or your mesh daemon advertises, or your gateway then translates, you could then declaratively create Kubernetes deployments requesting those resources created by Aukri, and that ensures that it's running on the correct node. And also ensures that not too many workloads are using it at once, et cetera. But it just depends on whether people want that level of like declarativeness. Like it might be sufficient just to have someone know.
It's an issue because the whole idea to have a mesh is that these devices can roam basically, right? So if you go from one room to another room, you will switch gateway, but your application will continue working. I was more thinking in somehow, using Aukri to figure out if the node supports Bluetooth in the first place. So if this daemon set can be deployed there, and what I'm most struggling with is like, how do I manage this state? So how do I boot this new gateway with a pre-provisioned all the devices that it needs to have to see, or something like that. That's something I still haven't seen much examples of, but yeah.
Yeah, no, it's tricky. And just clarifying question, when you talk about the device being able to move and the application following, are you saying that pod moves to the next node that can see it, or are you saying this?
No, it's just the Bluetooth, right? If all the nodes are the Bluetooth enabled and part of the same mesh, so this node will lose the Bluetooth connection, but the other one will pick it up. That's the whole point, and that gateway will then continue to pick up the data from the device.
Okay,
that's
so
how you get more range and everything. So,
and that's because the radio on each one of those nodes is kind of adding it to the mesh, you're saying?
Yeah.
Okay, so, and because you spaced out the nodes, you've furthered the mesh. Okay, and so then it doesn't matter where the device runs. So it sounds like, sorry, it doesn't matter where the application runs. I mean, in this sense, it sounds
application. There's an application on the device, right? There's an application in the cloud, and the gateway there is only to get the data back and forth, right? Get things from the radio, from the mesh, and get it into the cloud.
What about if you want to process it locally?
You can, yeah. We're not there yet, but yeah, that's also.
So if you wanted to process it locally on node A for some Bluetooth device that's close to node C, that's fine, because that mesh daemon can get that information. Because it's a part of the mesh. Just wanted to clarify. I mean,
but we would need to implement something that will basically. Right now, what we're doing, we're getting everything from and sending it to the cloud, right? What we need to do is to create those gateways a little bit smarter, to know, to create an IP mesh that will map the radio mesh, right? That we have. So, and I think that's something. Yeah, I see where you're going, and I think that is something Aukri can help with. Right, and in the sense that we are saying now, for this particular Bluetooth device, don't send things to the cloud, send this to this local pod running on the edge. And I think that's a very, very powerful use case.
Yeah, so just to clarify, I think
no,
you
it's
answered this, but
cool.
I just
Yeah.
want to make sure. It also could be that I'm a little tired, but when you say that it doesn't matter where the device moves, is that because you're collecting all the data and sending it to the cloud, or is that literally because Gateway app on node A can access the data? Okay,
The first one, yeah.
okay.
But it all depends how we implement things. So from the mesh, from the Bluetooth perspective, every device just broadcasts everything it has, and every device listens to everything that comes to it. So every gateway, so we have device and we have nodes, right? So every node will receive everything that it have, right? So every gateway service that we have at the moment will receive everything that every device it has publishes locally. So what we do at the moment is just send everything to the cloud, dedupe there, and push it forward to the stack. But in theory, those gateway services, we control them, so they can do much more local things. They can, as you said, do some local processing based on a lot of stuff. But yeah, that needs to be implemented. But it's technically doable. Yeah.
That makes sense. Yeah, this is really neat. And super
Yeah.
cool to look at. Thanks for sharing it all.
No worries. Thanks for listening. And yeah, I'll be providing updates from time to time. And if you have any ideas, interest, or anything, just ping.
Awesome. Well,
Cool.
I hope you have a good day. I'm gonna go have a good
Thanks.
night.
Thanks. Yeah. Take some rest.
But
Yeah.
I'll talk to you later.
Yeah. Take care.
Bye.
Bye.